In this video, I'm going to show you how to draw a free body diagram. Okay, so how to draw a free body diagram. Yeah, and it's quite easy. Free body diagram for a block, let's say mass M. Yeah. Okay, so the mass is M, and this is the string with the tension T. Yeah. So how are we gonna draw? So what you remember is you have to draw this first small mass like this, without anything attached to it. It is the same mass. It is the same mass which is attached to a string, but we are just analyzing it to draw a free body diagram. Okay, so we have to remember how the forces act. We have to remember that the tension acts always upwards in this way. Yeah. Tension acts upward, and this is with gravity. We have to remember that the gravity acts downwards. So gravity always acts downwards. So the gravity force will be mg. Yeah. So now are you missing something? So only thing that so that means that we have to write some free body diagram would be something like this. T acts here, mg acts downwards. This is the free body diagram. It's quite easy. So free body diagram is nothing but the forces acting on a body, or forces acting on a simple body with mass m, or anything with some given mass. So it's quite easy actually to draw a free body diagram, and it's one of the tools for solving problems of Newton's laws of equation. So yeah, so I'll show you one more example, and then you'll be quite clear with it. Yeah, okay. I'll show you the example with a pulley. Yeah. Let's try. Okay. Yeah. See. So I'll show it here. Yeah. Okay. We draw a pulley here. Then we draw something like this. Okay, and we draw a mass m here. Yeah, and we apply a force, let's say 2 Newton. Okay, so now what would be the free body diagram? Okay, what would be the free body diagram here? Yeah. So we have to remember that this is frictionless. Okay, this is frictionless, but this is frictionless surface. Yeah. So what I'm gonna do is, so what you're gonna do here is you draw the diagram. You have to first think is of about the free body diagram of a mass. So we draw it similar way I did it before. We draw it like without anything attached to it, and show that this is the same thing as the M. I'm drawing it here, and then I'll show the forces attached to it. We have to remember tension always acts out of the opposite direction as the force is this side, so tension will act the other side. So tension will be something like this. T. Tension is a pulling force of this mass M. Okay. So from the string. Okay. Anyways, so this would be 2 Newton. Yeah. 2 Newton. So this is frictionless, so it will be something like this: T minus 2n equal to ma, assuming that the tension force is greater than the Newton force. Or we can write it something like this: if it's normally assumed that the Newton force is greater than the tension force. So if it's like that, if the Newton force is greater than the force applied is greater than the tension force, it would be something like this. Okay, anyways, it's just the opposite. Yeah. Okay, so now I will tell you one more thing, that if the body has friction, if the body has friction, let's say it has friction, if the a body, in the sense, if the floor has friction, if the floor has friction, so what are you going to do? Now what are you going to do? So for friction, if 2 Newton is applied here, the friction would be this side. Okay, so the equation will be something like this: T plus F minus 2 equal to ma. Exactly. It's quite easy. Now, and how are you going to write the friction force? Friction force is nothing but F is equal to mu n. So F equal to mu n. N is the, what is n? I'll tell you what is n. So n is nothing but the normal force. If any smart guys over there would have already understood that I didn't mention the y-axis forces, I only mentioned the x-axis forces. Okay, so the smart guys over there would have understood that I forgot to mention the Newton force. What is Newton force? Newton force, if you put something on a floor, you will always put some mass on a floor, you always get a normal force, not Newton force, I'm sorry, or normal force above the ground. So what is a normal force? I'll tell you. Normal force is this, which is above, which acts above the ground, which it's placed. So now what will be the friction force here? F is equal to mu, and n is nothing but n equal to mg downwards. So the x-axis force is now complete. The x-axis force already complete. The y-axis force is now complete. N is this. So this would be nothing but n equal to mg. That's it. So we get the value of mu is equal to mg. Mu is the coefficient of friction, which would actually be given in problems. Here the floor is with friction, mu. So coefficient of friction with mu. Okay. So now we are going to apply this here. We get something like this: Vt plus mu m g minus 2 equal to m a. So that's it. So thank you. You get value this. you get something, you get the equation something like this. Okay, so this is how you write the free body diagram, and for how to draw a free body diagram, and I also explained how to write the forces on the free body diagram. So I hope this video is helpful, and I would like the viewers to subscribe for my channel. Thank you.